You have probably seen H2O drawn similar to this. But to understand its properties, we must look closer at how the electrons are shared between the atoms. The distinctive V-shape can be explained by the principles of bent molecular geometry. This theory states that the physical structure of molecules directly influence their properties and behaviors. Electron pairs surrounding an atom repel each other and will therefore arrange themselves to be as far apart as possible. In the case of a water molecule, the oxygen atom has two pairs of electrons that are not shared with the hydrogen atoms, also known as lone pairs. Because the repulsion from these lone pairs is greater than the repulsion from the shared electron pairs, the result is a bent molecular structure. The oxygen atom also shares one electron with each of the hydrogen atoms in order to create a more stable molecule. This sharing of electrons between the atoms creates a strong bond, which is also known as a covalent bond. It is important to remember that these strong electromagnetic bonds are restless vibratory entities and not solid tubes. The electrons are not stationary, but exist in quantum mechanical orbitals or electron clouds that are shared between the two atoms. However, these electrons are not shared equally. Because the oxygen atom is more electronegative, it pulls the electrons slightly closer to itself. This results in a slight negative charge near the oxygen, while the hydrogen side carries a slight positive charge. Because of these opposite charges, H2O becomes a polar molecule. And because it's a polar molecule, it now attracts other water molecules that are also polar. These oppositely charged atoms now form bonds that are called hydrogen bonds, with up to 4 other different water molecules. The hydrogen bond is not as strong as the covalent bond, but provides the key to understanding water's behavior and characteristics.